In this problem, if you read it over, you see there's an equation given here, and that equation tells me what the lift of a wing is, the lift of an airplane wing. Wings of an airplane lift the plane up in the air, that's how it flies, based on how the wind is moving over the wings. When the wing has wind moving over it, it generates lift upwards. Now, I've written the equation right here. I've written this original equation. See, I brought that guy down here. And I've put some variables into it that I want you to spend just a minute reading from this paragraph. See, I've got my 0.2 grams per liter. That's my density. And I've got my, let's use a different highlighter color. Let's use green for velocity. I've got my wind speed right there. Notice how I've put those into the equation. C and A, I left dark blue because we don't know what those are. Those are mysterious. There's all sorts of things they could be, and it's not worth spending any time worrying about it because they're not given to you. So we just have to leave those as they are. Now, what's the question? Look what this is asking now. I'm going to underline these. It's saying, what's the maximum lift force in pounds that a 40-mile-an-hour wind, okay, so look at that, that's interesting. The wind speed is changing to 40 miles an hour instead of 160, and the density of air is changing also to 0.8 instead of 0.2. So it sounds like this airplane is coming down in altitude and slowing down. And they want to know what's going to happen to the lift force now. It was 1,000. How does it change? Well, think about what's happening here. Oops, I'm in a highlighter mode. Hold on. I'm going to try to write this equation with as much as I know in it, and there's some stuff missing. So question mark, this lift equals, well, there's a C and there's an A and there's a divided by 2. I know those. But what do I know that has happened to the density, for example? The density is now 4 times thicker air. Okay, the density value has gone up by times 4. But if you look at the velocity, something different happens. Velocity got cut from 160 down to 40. That's like getting cut by a quarter. Okay, so I'll write 1 divided by 4 there, and it's still going to be squared. So the question is, if before I got 1,000, well, what's happening here? Let's look at the effects, and we'll track them one at a time. This is how you deal with what's called proportionality equations. I start with my 1,000s, and then I say, okay, the air got 4 times thicker. Okay, so now we're going to say times 4. And now, not only did the air get 4 times thicker, but, dang it, I'm the highlighter again. Not only did the air get 4 times thicker, but the velocity dropped. So that's going to be 1/4 squared, according to the equation. And some of this should make sense, right? If the airplane is going slower, it's not going to have as much lift. You see, that's the fraction taking effect. If the air is thicker, it will have more lift because there's more air to lift it up. So if I take my calculator now and I say 1,000 times 4 times 1 divided by 4 squared, here's what I'm writing, just so you can see what I'm doing here. I'm saying 1,000 times 4 times 1/4 squared. Those of you who are comfortable with fractions can probably do this in your head. The 4 and the 1/4 are going to cancel each other out, and what's left is only one factor of 1/4, and that's going to turn into 250. In other words, the lift force on the wings has gone down because even though the air is denser, the velocity has dropped, and the velocity, according to this equation, has a bigger effect.